Hello, everybody. My name's Rob Keizer. I'm going to be talking about misusing video services, storage systems, specifically looking at QR code stuff. Let me just take a quick look. Yeah, there's me. I'm around. I do public cloud hosting here in Winnipeg, so if you want to talk to me about that, go ahead. I'm currently CTO at Ukkö Robotics. We make autonomous chicken barns, which is kind of cool. And I'm a director over at Coldhak, a few other things. There's a standard disclaimer about the talk. Generally speaking, this is me and only me. I do not represent any of the companies that I happen to be part of or organizations. So if you take offense to this, if I violate something, if I do whatever, this is me. So just don't bias yourself with what I say here. Yeah. All right. Also, I make absolutely no warranties about stuff in this talk. So if it breaks, you get all the pieces. If you do this, you're on your own. I did not instruct you to do this. I'm not a lawyer, but seriously, don't do this unless you know what you're doing. This slide is important. So I wanted to say thank you to the organizers since nobody's done it yet so far. You guys have managed to put on an amazing event. So thank you guys. And in all seriousness, the guys with the red shirts and the yellow shirts are what make this possible. And thank you especially for Dylan for being on my ass about sponsoring things, because he's done an amazing job. This year has been more than ever managing to get sponsors, so that's awesome. So a really quick overview of what I'm going to talk about. Nothing that crazy. I'm going to talk about QR codes a little bit, just because some background, not much. There's an aside that I'm going to ask to not be recorded, but that's only because I added it this morning and I didn't really think clearly about whether or not it would be appropriate to have recordings of it. And then some background about some video services that currently exist, some of the technical details of them. We're going to talk about Fuse, file systems and user space, not, again, in terribly detail because I don't really care and it's not pertinent to this conversation. We're going to go over what I did, which, if you can't see the screen, I don't know, is that half decent large text? Yeah, awesome, good, that's awesome. So effectively, I did QR encoding with FFmpeg and backed it by a Fuse file system, which we'll go over what that is. And then some notes about going further. All the while, if you have questions, please yell at me. Also, we're out of coffee, so I found that out. Damn it, okay. So if you have any questions, please just do yell, raise your hand, get my attention somehow. I'm not going to take offense to it, and yeah, we'll go from there. So first and foremost, sorry. I bought a house and some property. This is not as good as it could have been, and I'm a procrastinator. I was literally typing this up at 9 a.m. at Salisbury House this morning. So I did the thing, sort of, but you should take this as a, here's some cool shit that you should go and look at further. Not a, look what I did, it's special and shiny, okay? So just as a forewarning. I'm also not going to waste your time by trying to fill the time. So if I'm done early, I'll just be done early. You can ask me questions or not. So really quick, simple QR codes. Most people have seen them. Also, don't bloody scan these. We're at a security conference. I don't know what they are. I just pulled them off the line. I'm pretty sure it's Wikipedia, like link to English, whatever. But generally speaking, it's, you should know, you should trust the content, and I wouldn't trust me on this. Yeah, as Mac is doing it. Anyways, so two-dimensional bar. Yeah, that's two. So it's two-dimensional barcodes, effectively. There's a lot more on that besides just that. We'll go over it. It originally comes from Japan, Denso specifically. If you haven't got a chance or you haven't heard of that name, they make awesome robotic arms. They're one of two that make really cool robotic arms for like manufacturing. They're fun to play with. QR codes have multiple versions, and that translates to how big they can be, what kind of, yeah, we'll get into that a little bit, but there's multiple versions of QR codes. And they are agnostic as to what they hold. So you can store whatever you want in them. They're just storing bytes. That's literally it. They're handy for encoding things. They have some knobs to fiddle, not too many, but a few. You can change how much error correction they have, that kind of stuff. So yeah, it can be really dense, and they have correction built into them. And you can change how much duplication of the content it has, and therefore how much, you know, how much you can chop off. For example, the middle thing is actually a valid QR code, even though it's got random, I don't even know, a guy on a motorcycle in it. So it is totally valid. So they can be dense. I really do mean dense. The spec on this is very, very dense. I don't know what that is, again. so I wouldn't scan it, because I don't know what it is. But there is no real technical. You could easily take the spec of QR and extend it to be arbitrary length if you chose to. Okay? Everybody good on that? Right, so a quick note. I use QR codes to back up my private keys. I take my private key, I print it, I change it into QR codes, and I print it on paper. And then that goes into a safety deposit box. Because humans are really good at storing information on paper, generally, for long periods of time. I don't really trust my flash drive, even in a safety deposit box, for 5 years. I don't. It's likely to be fine. CDRs are likely to be fine. This is a hell of a lot easier, and it's paper. So it's handy. If you want to transport data securely, consider this. So yeah, so libqr encode, it's a thing. It is a library. It does QR encoding. It has pretty good performance. All right, and we're going to go over this. Again, I'm not going to waste your time. This is view full screen. I'm not going to go over all of it. This came out a couple days ago on Reddit. It's an awesome step-by-step guide. I'll put up a link and everything else, but effectively what it is you take your data, you group data, you then fit into versions based on the number of code words. So code words translates to versions. A certain version can store X number of code words at a given error correction rate. It's basically how much data can you actually store in a given thing, in a given image. You then basically, once you have your data, you then see which level of error correction and version you end up using. You use a very specific way to basically encode your data into this. Then you split them, add error correction. So you can see that's the actual data in this case, and then the error correction is just at the bottom. It's Reed-Solomon error correction codes, in case anybody cares. And then you start with the drawing. I'm not going to go over this in detail. Like I said, this is an awesome resource. But effectively, there is a specific way in which you draw a QR code, and it's step by step. And it is one for one. So given the same data, there should only be one QR code. There could be multiple QR codes that are invalid in terms of they represent the same data because there are different versions, there are different sizes. But because everybody is standardized on a spec, it's like a hash, almost. One set of data should always equate to one image of QR. That image could be different. It could be a PNG, JPEG, all this other stuff. But as far as QR representations go, it should be the same. You then basically take all your code words, starting at the bottom over here, and all you do is go ones and zeros all the way up. And that's all you do. And then you end up with that, which then you apply a mask onto. And masks, effectively, the type of mask you pick is directly related. You basically apply a mask, and the mask you pick is derived from the penalty patterns. And the penalty patterns are effectively, there's a lot of stuff in a single row. So there's a lot of the same character. And all you do is you basically count how many penalty points you have, or how many bad things you have in the QR code. And if you do that for a whole bunch of different masks, and you pick the one that has the best mask, and that's the one you use. And it's programmatic in the way in which it determines that. So you should always end up with the same QR code given the same data and the same version of QR. Yeah, that's basically it. Awesome site, highly recommend. Video streaming services, really quick overview. YouTube, 60 frames a second, 4K resolution, 50 megabit stream, and that's RTMP live streaming. So that gives you about 50 megabit of transit, of actual, like, this is the stream. If you had a 50 megabit upload, which lots of people in this room do, you could stream 4K out the door, and they'd take it. And then they would broadcast that out, again, 4K. Google Edge, this is basically peering DB, or like where you can talk to Google directly. If you're an ISP, it's all over the world. And that is important later. I'm not just randomly including shit. Some terms of service that I took a really quick gander at earlier today, for example. I noticed that YouTube basically says if you have an unauthorized use of your account, you might be reliable. You might be responsible for damages, but the inverse is not true. YouTube isn't. That's just a dick move. But the important thing is that you agree not to launch any automated systems, including without limitation, robots, spiders, or offline readers that blah 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 blah. reasonable human. So you have to, if you're going to create automated software, it has to mimic, at least in some form, the amount of requests that a human could reasonably click on a website. So you can't just spam them, basically, is what it comes down to. What I'm doing could, but you could also rate limit it. So, yeah. Vimeo, 60 frames a second, 8K resolution. It doesn't do live stuff as far as I know, but it's 50 to 80 megabit per stream. Uses H.264 in the back end, as does YouTube. 360K audio at 48 kilohertz. Basically, I'm just saying there's some data there. You can mess with it. Twitch is another streaming system, 60 frames a second, 1080p. They offer 3 to 6 megabit streaming as suggested, and they very strongly enforce CBR, which is a constant bit rate. So for those of you doing video stuff, you'll know what this is. Basically, you can have video streams that get larger as the differences get larger in a stream. So say I'm moving around a lot, and suddenly these pixels around me are going to change a lot more than me standing here silently. It's just, you're not going to, it's deltas, right? Deltas of deltas. So you're not going to, CBR, it's important because it puts a bound on how much data you're going to shove out the door at a given time. So, Fuse, really simply. I'm using Node Fuse. It's a file system in user space. So take your favorite programming language, you can define a file system. That allows you to mount it so that you run, once you run the code, every single operation that your file system does, that any programs do at your OS layer get kicked back to your program. So for example, a read-dir request will just magically appear in your program, and you can handle that however you'd like. So why do you care about any of this shit? You can do some infinite storage stuff. So if you haven't caught on, the whole point is to be able to use YouTube as a storage mechanism and or transport mechanism or other video services. So there's no limit to how much you can shove onto YouTube right now at all. So the current estimates were thousands and thousands of hours of video per hour are being uploaded to YouTube right now. That's probably low at this point. So you really could decide to have a massive, massive file system and just encode it into YouTube videos and then pull it back out whenever you want from wherever you want. It's awesome for backups because you can make videos private. You can also do sharing, all that kind of stuff. And sharing a file. You can share a video. And when I say share a video, I don't mean in the sense of, here's this link. I mean, you can change permissions such that only certain accounts have access. So it would be possible for you to create subsets and file system permissions effectively with something like this. You can do packets in eBPF. So eBPF is effectively Berkeley packet filter stuff. Originally, it's Linux kernel stuff. It is designed to allow you to hook on to certain system calls, but it actually runs code. So you give it code. The code has some limitations, can't have certain loops, that kind of stuff. But it allows, it's controllable through user space, and it runs in the kernel. So it allows you to, for example, fake a packet going, well, not even fake a packet, it allows you to trigger a packet going outbound on a network interface, bypassing your entire network stack. It also allows you to basically hook on a file system or anything else and trigger a packet inbound. So your entire Linux system will see like a packet came in to EN0 or ETH0, but that packet didn't actually come over the wire. But your kernel said it came in over the wire, so all of your other network stack thinks it did. So this is how you could use, basically you could create live streaming, which by the way I did, but it's not sort of, Live streaming, bidirectional, you could create a tunnel quite easily and use this to actually route packets, with the idea being you do ping on one interface and layer 2 or layer 3, whichever you set up, goes encoded into YouTube Live, out the door on a video stream, and decoded at the other end, and vice versa. Yeah, so you could do YouTube 0. Again, it is possible to do that kind of stuff. And I kind of want to try this, but I'll talk to Theo about it somewhere. I think he's around now. But you could peer it with Google in Seattle and Tokyo, or any other place you want. And they don't actually charge for peering. In fact, they want you to peer with them, right? So if I wanted to have transit across the Pacific, I could actually just have my routers QR encode things, arbitrary data, and route it over that. So it's effectively IP over YouTube, but I'm not paying for transatlantic or trans-Pacific transit. I just appear in Tokyo. Also, it is the mother of all multicast, right? Like, so anybody, like one to many, YouTube has about a 5-second delay, I think, is what they publish. 5 seconds globally. So that's pretty good as far as multicast goes with very high bit rates. And backups. If I wanted to back up a file, I go, here you go, thunk, toss it on YouTube in this format. Anywhere in the world can listen on that either live or download it and get that backup. So it would be relatively trivial to build a one-to-many backup system that was global, and you're not paying for the transit. So it's you upload once, and you can distribute it that way. So some notes, YouTube Live requires an audio stream. This is not mentioned in any of their docs. So if you're going to do this, it took me about 2 days to figure out what the hell was going on and why I couldn't actually, the stream will start, and then it will simply say, I don't detect a stream, and die, even though FFmpeg is like running and giving it data. Use a null source or something like that. Basically put in a blank audio channel in your stream, and it's quite happy to run. There are C++ implementations of QR encode decode that are fairly good, that are well understood. Like the website I went over, there's a very specific way in which you do that, and you can optimize for that. And steganography, everybody's going to talk about this probably. I've heard 5 people mention it so far before this talk. Yes, it is possible to use this as a form of steganography, because all I'm doing is basically taking QR. I'm not hiding it, just to be clear. It's just you'll see in a second, it's just a video of QR codes. It's very obvious that it's something weird. But you could take an actual video, overlay QR codes on top with a certain, or just manipulate pixels if you wanted to, or anything like that, and get it back out. And you'd end up with basically hidden messages and steganography in the video streams or files. So, hold on. I've got a couple other things I wanted to show you. So this is what it looks like. How am I doing on time? 5, 10? I'm good. Yeah, cool. So, as you can see, that is actually some data that I saved. That's all it is. The reason why I chose QR to start with is because, so a friend of mine came and basically said, why don't you just use the raw data frames and like put arbitrary data in so it doesn't even look like anything, right? It's just garbage on the video stream. I'm using the qualities of video specifically because it has error correction capabilities. You notice that that's really fuzzy right now on the edges, but that's because YouTube actually resized it. I'm streaming from a mobile device. I'm also enlarging it like heck. But there's no guarantee that your endpoints will actually have the same kind of bandwidth down as you had up. So they will automatically resize video. QR would allow you to handle resizing video. It would allow you to handle weird issues like that. Yeah, so there's that. I've mentioned that. So those are just some videos. I wanted to mention, I'll go over how I did this really quick. How are we doing? Look good? Oh, shit. Thank goodness for TMUX. Everybody see that? Ish, sort of. Basically, you can generate some images, which is really simple. QR encode is piped operator, so you can use the Unix terminal. All I'm doing is going through a loop and echoing something, piping it to QR encode. Convert it is important because it needs to be divisible by 2. Otherwise, the stream on FFmpeg will not take it. So whatever you're using, just make sure it's divisible by 2. So that's, you can generate, basically you can generate images. Those images look, of course it's not going to actually open the directory, but they look like stills of that. You can then use, go through that. Yeah. You can then basically literally cat them all together, pipe it to NC. This is important because FFmpeg, if you try and create a handle for FFmpeg and just feed it data in on standard in, it doesn't really like it. FFmpeg doesn't care, but most of the tools that you use to feed data in really don't like it because your encoding is not correct or you're using new lines or something else. So if you use NC on both sides of it, you can basically just feed data into FFmpeg. The command right here basically says so I'm using FFmpeg, if that hasn't been clear already, and all it does is it takes a bunch of images in and it says a frame rate, and that means, and dash R at the end of that will say FFmpeg is saying there's no difference in the frame rate coming in, but I'm going to repeat the frame. So you've got a whole bunch of duplicate frames in there, but that keeps the frame rate up on the actual video so that YouTube sees 25 frames a second. Because because if you give it 1 frame a second, it's not going to do it. You can then effectively use this exact same thing to get it out with FFmpeg. So this is where you'd actually go and upload it. I got this half working, and then I broke it before the demo. Sorry. But the effect is that you could take that video. So that's what it actually looks like. It's just an MP4 video, but you could do whatever you want with that. You could distribute it, you could upload it, you could have it live stream, all that kind of stuff. And then you use an FFmpeg command to rip it all out. So what that does is it says, go at this video file, frame rate of 1, so 1 frame a second, and just save it, output images. You can, so I'm going to show you this. These 2 files, so I've got 2 directories here. Test images, which is basically I just iterated and created images of data, and output images, which are derived after I've basically taken the video and then basically ripped out the frames and put them back. They are different. That's because it's gone through video encoding. So they are not binary exact the same. But the big thing is that the content that is encoded in them is. So that, and then that. So you can see that the QR code, this is example stuff 1, is the same. That's actually the data that's encoded in that stream. So even though they are completely different images, the content in them is the same. Yeah, I don't think I had too much else. Live streaming, really simply image PNGs into a frame, blah, blah, blah. This is from an older presentation. But yeah, that's pretty much it. Questions? Yeah. So I have done some load tests on it, and I've gotten about 40 megabit is what I can get throughput. And that's based on 60 frames a second at, I think I did 1080p for that test. But theoretically, especially if you wanted to not do live streaming, right? If you wanted to just do upload video, it would be pretty much perfect because you're taking a massive file and uploading it. So that might take a while. There's latency involved in that, but YouTube will have a correct copy of it. And as long as you have a really high download rate, YouTube will not resize on you, or it won't resize much on you, which means that the data coming back out will be full representation. And the result of that is that you can, it's high latency, but the bandwidth is there. The bandwidth is effectively, you're losing about 30% by default with QR on the encoding because it has default error corrections, but you can disable that. You can say, I don't want error correction, and then you're losing a whole bunch because of pixels and all this other stuff. I was able to push 40 megabit through it, but I mean, yeah, that was my test. Yeah. Yeah.
You mentioned that you could restrict people based on their YouTube accounts from seeing the data, but how does that restrict YouTube themselves from actually seeing the data, right? Like they could probably have access to all those accounts and all that stream and then just recompile your data. Have you ever thought about encrypting your data before you QR'd it?
Yeah, definitely. So that is, it was effectively a question around have I thought about encrypting the data before you QR encode it? Yes, and that is how I would suggest if you want to play with this, you do that. Then you're basically, even if somebody bothers to download the YouTube stream or the file and decode it, they're getting encrypted data. And there's nothing saying you couldn't do that beforehand. So it is, and QR, that's another reason why QR is really handy in this aspect. It is completely arbitrary what you store in there. So, yeah. 100 meg video, it depends on what your frame rate is and a whole bunch of knobs and buttons, basically. So how fast you change the frame rate will determine, yeah, there's a whole bunch of knobs and buttons. I can tell you that, well, here, let's just do this. Test images. I did not take a look at the file size completely. I did speed. But so if I'm doing this, I can just do an grep for PNG. Well, these are on disk, right? So they're taking 3K a piece because they're on disk through inodes. They're not all 3K a piece, I don't think. Anyways, I would suggest that it's probably not that difficult to test it. And it's important to note that it's not based on time. So when you're talking about file size, it isn't going to be based on duration of the video. The reason is you've got a whole bunch of duplicate frames in there. So it's going to compress that down a heck. So the result is, simple answer, the question, let's get back to it. The question was, if I had 100 megs, how big is the video? Simple answer is I don't know because I haven't done that test. I can tell you that if you had 100 megs, it would take you, I don't know, what's it, 30 megabit, 40 megabit upload. You can get that data out the door. Yeah, I didn't time it, so I don't know. It's a simple answer. Any other questions, concerns? I'm crazy, yeah. All right, cool. If you want to talk about this stuff, come find me. I am hoping to do QR stuff in the future. I want to create, oh God, maybe not Electron app, but some cross-platform thing that you can then just literally, oh yeah, here's your file system, and you're good to go. But right now, the shell scripts work, and if you want, I can give them to you and or open source them, and they are simply to encode and decode data and shove it onto YouTube, which works. All right, see you guys later.